In this video, we're going to look at how to graph a tangent function. So to start off with, we're going to use our unit circle to get a basic tangent graph, and then from there we'll look at our transformation rules. Okay, if you'll notice in my XY chart, this is a little bit different from sine and cosine. With sine and cosine, we started at 0 and we worked our way around the unit circle, hitting the axes. Okay, for this one, because tangent's period is smaller than sine and cosine, we're having to count by smaller increments. And I also started with negative pi halves, and you'll see why once we draw the graph. But remember, a negative angle, instead of opening up, opens down. So negative pi halves is really starting here. So it's the same as 3 pi halves down here. And then going to negative pi fourths, which would really be 7 pi fourths, and then to 0, and then to pi fourths and pi halves. So let's use those 5 angles and fill in our XY chart. And remember that tangent is sine over cosine or y over x. So that's how we're going to get our values. So starting at negative pi halves down here, our y is -1, our x is 0. -1 divided by 0 is undefined. Okay, when we get to negative pi fourths, our sine is negative square root 2 over 2. Our cosine's positive square root 2 over 2. When you divide those out, you're going to get -1. At 0, our y divided by x, or sine divided by cosine, is 0 over 1. 0 over 1 is 0. Pi fourths, y divided by x, they're the same thing, so you're going to get 1. And then for pi halves, y divided by x is undefined again. All right, so let's label our graph from negative pi halves to pi halves. So I've got negative pi halves here, negative pi fourths, 0 on the y-axis, pi fourths here, and pi halves here. And then for my y-axis, we'll just go 1 and -1. Okay, everywhere we have an undefined, that's going to be a vertical asymptote. So at negative pi halves, we have a vertical asymptote. At negative pi fourths, we have the point -1. Then we have a point at 0, 0. Then we have a point at pi fourths 1. And pi halves is undefined again, so there's another vertical asymptote. And so all you have to create your graph with are 3 dots. But if you can remember that the tangent graph resembles the cubic graph, remember a cubic graph kind of does this number. It curves up and gets closer to that asymptote, and then it's going to curve down and get closer to this one. Now, a normal cubic function doesn't have these asymptotes, but it's got the same basic shape as a cubic function. So notice the period of tangent. We have already talked about this before, but rather than being 2 pi, the period of a tangent function is just pi. So from one asymptote to another is 1 period. And so now that you see where these asymptotes are, you see why I wanted to set my table up like that. And then remember, you always want to graph 2 full periods. So then we're going to keep on counting forward to get to our next asymptote. So we're counting up by 1/4 each time. So after pi halves would be 3 pi fourths, just continuing around the unit circle. After that, we would be at pi. Then we would be at 5 pi fourths, and then we would be at 3 pi halves. And that's where our next asymptote would fall. And then we have this same pattern all over again. This point is going to be at -1, the center's at 0, and then the one on the right is at +1. So when you graph a tangent function, make sure you're always showing 2 little cubic looking graphs. Now, tangent functions do have period. They don't have amplitude. Remember, with sine and cosine, amplitude was the distance from your midline to the highest or lowest point. And tangent graphs don't have a highest or lowest point because they go on to infinity up here and to negative infinity down here. So we don't call it amplitude, but we can have a stretch or a shrink. So if this is your tangent equation, everything's really similar to sine and cosine except for your A. That's not your amplitude anymore. Your A is your vertical stretch or your vertical shrink. So I'm going to write stretch and shrink comes from your A value. Your period, we normally do 2 pi divided by b, but with tangent we just do pi divided by b. The phase shift is still c divided by b, just like sine and cosine, and then remember with sine and cosine, positive is left, negative is right. It's opposite of what you would think. And then your vertical shift is still your d value. Positive is up, negative is down. Okay, so we're going to graph a couple of these. All right, so for the first one, let me move this out of the way. For the first one, you have y equals 3 tangent 2x. So let's go ahead and write what we know. This is our A, this is our B. We don't have a C or a D. So we know that we have a stretch by a factor of 3. And when we're talking about stretches and shrinks, if you remember in your Math 171 class, when this value out here is greater than 1, it makes your graph steeper. It's like you take the top and the bottom of your graph and you pull it and you're stretching it vertically. When this number is between 0 and 1, so some sort of decimal or fraction like 1/2 or 2/3 or 0.75, that's a shrink, and it's like you're taking your graph and you're compressing it this way and you're making it a little bit flatter. If the number out front is negative, the negative is actually a flip or a reflection. So you're only focused on the number itself, not what sign the number has. Okay, so this one's stretched by a factor of 3, so it's 3 times as steep. Okay, for the period, we take pi and we divide by b, and b is 2, so our period's pi halves. Okay, so before I draw this out, we're going to approach tangent graphs a little bit differently than sine and cosine. With sine and cosine, we started with our phase shift, and that kind of told us where to start our graph at. Because tangent is undefined at pi halves and multiples of pi halves, we're going to take our angle that we're finding the tangent of, and we're going to set that equal to pi halves every time and solve that small equation, and that'll tell us the x value where one of our asymptotes occurs. And once we have that first asymptote down pat, then we can take our period and get our next asymptote. So we're going to approach these just a little bit different. So you may want to make yourself a note that you're going to set your angle equal to pi halves and then solve that. That's going to give you your first asymptote. Okay, so let's do that. Our angle is 2x. If we set that equal to pi halves and solve, we would have to divide this side by 2. So x is going to be pi halves divided by 2. But remember, dividing by 2 is multiplying by 1/2. So our asymptote is actually going to occur at pi fourths. Okay, so when we draw our tangent graph, that's where we're going to put our first asymptote at. We also, before we do that, we also need to know what we're going to count by. Remember, with the sine and cosine graphs, we always took our period and we divided by 4 because they're broken into 4 equal parts. Tangent is the same way. Every tangent function has 1, 2, 3, 4 equal parts. So if you take your period and divide by 4 or multiply by 1/4, we know that we've got to count by pi eighths. Okay, so go ahead and put your first asymptote at pi fourths like we said. But we know we have to count by pi eighths 4 times to get to our next asymptote. Now, because our asymptote's right here, there's two ways you can go. You can go forward by pi eighths and get the next asymptote out here. You can go backwards by pi eighths and get the next asymptote out here. Because you have to show 2 periods, you technically need to go both directions. So I'm going to go backwards first, and then I'll come in and go forward. So if you're at 1/4, and I've got my calculator here for those of you that are not great at fractions in your head, but if you're at 1/4 and you're going to go back by 1/8, that's just going to put you at 1/8. So right here is going to be pi-8ths. And then if you go back another 1/8, you're at 0. So our next tick mark is 0. Go back another 1/8, you're at negative 1/8, so negative pi-8ths. And go back another 1/8, and you are at negative 1/4. So negative pi-4ths would be here, and that's our next asymptote. All right, now let's go forward. We were at 1/4. We're adding 1/8 to that. Puts us at 3 pi-8ths. Add another 1/8 to that. You're at 1/2 pi-halves. Add another 1/8. You're at 5 pi-8ths. And we need one more tick mark. Add another 1/8. And you're at 3 pi-4ths. So 1, 2, 3, 4, there's our next asymptote. Okay, so now you've kind of got your boundary lines. All you have to do now is go back in and fill your graph in. Keep in mind we had a stretch by a factor of 3. So looking up here at our basic graph, remember when we put our dots at 1 and -1, our dots are going to go at 3 and -3 now. So make sure that you label your y-axis up to 3 and down to -3. So the center one's always at 0. The one on the right is always at 3. The one on the left, well, not always at 3, but in this case it's always at 3. And then you're going to go up and down. Same thing over here. The one in the center at 0. The one on the right, 3. The one on the left, -3. And then this one's going to go up, and this one is going to go down. Okay. Let's look at a few more examples. Okay, on this sheet we have y equals 1 minus the tangent of x. All right, remember that your stretches and your shrinks are always right in front of the trig. And so there's an understood 1 here, which means we don't really have a stretch or a shrink. But this one right here is our d value. That's normally kind of back here on the end. It's in the front this time. Our b value is an understood 1. This would be our a value, an understood 1, and we don't have a c. Okay, so let's write down what we know. We don't have a stretch or a shrink. Our period is pi divided by b, but our b is just a 1, so our period is pi. We don't have a phase shift because of the c, but we do have a vertical shift of 1, and it's a positive 1, so it's going to be up 1 unit. And we do have to consider this negative. It doesn't affect our stretch or shrink, but a negative on your trig function flips your graph upside down. So we also have a reflection across the x-axis. So we need to remember that when we draw our tangent graph. All right, let's go ahead and sketch our coordinate plane. Might need to go out a little bit further. Now we know our graph is shifted up 1, so normally when I would just label 1 and -1, because I'm shifting everything up 1, I'm going to have to label at least up to 2 to get everything I need there. All right, to find our first asymptote, remember you take your angle, which in this case is just an x, and you set that equal to pi-halves and solve, but there's nothing to solve this time, so our first asymptote is at pi-halves. All right, so go ahead and choose your point to be pi-halves. Put your first asymptote. And then we're going to count backwards 4 times and forwards 4 times to get our other 2 asymptotes. Now, if our period is pi, when we divide that by 4, pi-4ths is what we're going to count by. So I'm going to count backwards first. If I'm at pi-halves and I go back a 4th, I'm at pi-4ths. If I go back another 4th, I'm at 0. If I go back another 4th, I'm at -1/4, and then another one would be at -1/2. So negative pi-halves would be the next asymptote. Then I'm going to go forward 4 times. If I'm at a half and I go forward by a fourth, that puts me at 3/4. Another fourth would put me at 1 whole, which is pi. Another fourth would put me at 5/4, and another fourth would put me at 3 pi halves, and that'll be your next asymptote. Okay, because this graph is shifted up 1 unit, I would take like a colored pencil or a highlighter or something and just kind of draw where you're going to imagine your new x-axis being. Treat that as kind of like your x-axis. These center points are still at 0, but now they're at 1 since they're shifted up. And when you draw your graph this time, because we had this reflection in the x-axis, instead of the one on the right being above and the one on the left being below, we're going to flip that. The one on the right is below, the one on the left is above, and your graph is going to have this shape to it. Same thing here. The one on the right is below by 1, the one on the left is above by 1, and that would be your basic shape. All right, let's look at number 3. Y equals the tangent of x over 2 plus pi fourths. All right, your A value is an understood 1, so no stretch or shrink. Your B value is a 1/2. There's an understood 1 in front of that x, so 1/2 for your B value. Your C is pi fourths, and then you don't have a D. All right, let's go ahead and write down what we know. The period is going to be pi divided by B, and B for this problem is 1/2. But remember that dividing by 1/2 is the same as multiplying by 2. So our period this time is 2 pi. So your graph's going to be a little bit wider than normal. For the phase shift, you're going to do C divided by B. C is pi fourths. B is 1/2. Okay, so you want to think of that as pi fourths times 2 over 1, which is going to give you 2 pi on the top and 4 on the bottom, which reduces to pi halves. So our phase shift is pi halves, and it's positive, so pi halves to the left would be the phase shift, and no vertical shift. Okay, let's draw this out. All right, let's go ahead and figure out where our first asymptote is going to be by taking our angle. This whole thing is our angle. So we have x over 2 plus pi fourths, and setting that equal to pi halves. Okay, so, and I'm sorry, this is kind of bright so you can't see it really well. If I'm going to solve this for x, the first thing that I would do would be subtract this pi fourths to the other side. So I'm going to have x over 2 equals pi halves minus pi fourths is pi fourths. Okay, my next step would be to get rid of this 2 in the denominator, so I'm going to multiply by 2. So x equals 2 pi over 4, so x is pi halves. So our first asymptote is at pi halves. So go ahead and pick a place to be pi halves. Put your first asymptote. Okay, the next thing for us to figure out is what are we going to count by? If our period was 2 pi, and we divide that by 4, we get pi halves for that as well. So we're starting at pi halves with our asymptote. We're also going to count by pi halves. Okay, so our graph is actually going to be a lot wider than I have mine drawn. So this is why you always want to do these in pencil to begin with. So I'm going to count backwards pi halves 4 times. So if I'm already at pi halves and I go backwards once, I'm at 0. If I go backwards again, I'm at negative pi halves. Backwards again, I'm at negative 1 or negative pi. So that's 1, 2, 3, and then one more would be negative 3 pi halves for the next asymptote. Okay, and I'm going to go forward 4 times. I'm at pi halves. If I go forward, I'm at pi. Go forward again, 3 pi halves. forward again, 2 pi, and then forward one more time would be 5 pi halves. And remember, all of this can be done in the calculator if you're not really comfortable doing fractions in your head. Okay, so there's my asymptotes. I didn't have any stretches or shrinks or flips or anything like that, so my graph has its normal shape. Remember, in the center, you're at 0, and then to the right, you're up 1, and to the left, you're down 1. Remember, you don't want your graph to ever cross the asymptotes. Okay, so that would be your graph for that one. Notice it is wider like we said it should be. And one more. Okay, for the last one, we have y equals 1/2 the tangent of 2x minus pi. All right, so this is A, B, and C, and we don't have a D. All right, so we already know that because our A is a 1/2, that's less than 1, so we're going to have a vertical shrink this time. Shrink by a factor of 1/2, so it's going to be 1/2 as steep as it normally would be. Okay, the period, we're going to do pi divided by b. Pi halves will be our period. And then for the phase shift, c divided by b, pi halves, and it's negative, so this will be pi halves to the right. Okay. Okay, let's go ahead and get our first asymptote by taking our angle, 2x minus pi, and setting that equal to pi halves. Okay, if I was going to solve that, I would add pi. So pi and pi halves gives me 3 pi halves. And then I would divide by 2. So that's going to give me 3 pi fourths for my first asymptote. So choose where you want your 3 pi fourths to be. And then we're going to figure out what we're going to count by in order to get to our next asymptote. So our period is pi halves. If we take that and we divide by 4 or multiply by 1/4, we get pi eighths. So pi eighths is what we're going to count by. Now this may be one you need the calculator on if you're not comfortable with it. But if our first asymptote is at 3/4, and I'm going to go backwards first, so I'm going to go back by 1/8, so minus 1/8, we get 5 pi eighths. Okay, so that'll be, I don't know, it's pretty small, so let's go right there. 5 pi eighths, go back another eighth, and we're at pi halves, go back another eighth, we're at 3 pi eighths, and go back another eighth, and we are at 1/4. Okay, so here's what I'm going to do. My graph is not placed the way I need it to be, so I'm going to just go back one more eighth and we were at pi fourths. So right here is my next asymptote. And then I'm going to let my x-axis be, let's see, or y-axis, sorry. I'll just put my y-axis there. Okay, I think we fixed that problem. Now, because I still have this gap right here between my y-axis and where my first asymptote is, and rather than going forward this time, I'm going to go back again 4 more times. So if I'm at pi fourths and I go back another eighth, I am at 1/8. So pi eighths would be here. This is really small. And then if I go back another eighth, obviously I'm at 0. Go back another eighth, I'm going to be at negative 1/8. and I go back one more eighth, then I'm going to be at negative 1/4, and that's the next asymptote. So this one is really small. Okay, we have a shrink by a factor of 1/2. So if this is 1 and this is negative 1, when I draw my graph, I have to make sure that I put my dots at 1/2, not at the 1, so halfway up. So here would be that one, and then this one at negative pi8, so we'd be down here at negative 1/2, and then 0 in the middle. And so you have this one and this one. Same thing here, 0 in the middle, and then 1/2, and then negative 1/2, and I know that that's kind of scrunched up. But that would be what your graph looks like, and I'm going to zoom in a little bit so you can see it better. Sometimes you don't know how your graph is going to work out until you start actually counting and you see that you've got too much room or not enough room. And so please always do these with pencil first so that you can erase and adjust whatever you need to adjust, rather than doing them in pen or marker or something like that and having to just start completely over. Always use a pencil.